This is the Pick Your Poison podcast. I'm your host, Dr. JP, and I'm here to share my passion for poisons in this interactive show. Will our patients survive this podcast? And today, will you survive this podcast? It's up to you and the choices you make. Our episode today is called Knockdown. Want to know how lack of smell might kill you? What lethal poison routinely kills rescuers yet is made in your body? Then listen to find out. Today's episode starts on a cruise ship. You're aboard for a conference, mixing business with pleasure and hoping to tip the scales toward pleasure. In fact, you're currently skipping the lecture to go to the spa. You become lost in the maze of corridors and end up in an area restricted to the crew. It smells horrible, like raw sewage. You get in a service elevator and push the button to go up. You hope it smells better in the spa. This is way too much like the air in the ER on a bad shift. The elevator goes down instead of up. You hadn't thought it possible, but now the smell is worse. The doors open to a level with pipes and electrical wires, presumably a maintenance area of some sort. At this rate, you're going to miss the spa appointment completely. This ship is approximately the size of a small city. There's a loud commotion at the other end of the hallway, with banging and shouting. Construction, maybe laundry facilities. A woman runs past with a backboard and a large bag with a red cross emblazoned on it. A first aid kit. You're about to let the door slide shut. This isn't your problem. Cruise ships have medical personnel equipped to handle these problems. A voice from the end of the hall says, "Call for help," in the same frantic tone you've heard outside the ER when somebody drives up with a gunshot victim in the back seat. Instead, you stick your hand out, preventing the elevator doors from closing, and step out. You're in a large room filled with equipment. At the opposite end, the woman with the backboard stops, asking a crew member standing outside the door, "What happened?" He says Mike passed out while trying to find the leak. Jose went in to help and passed out too. Before you can say anything, they rush through the doorway, still speaking in raised voices. She says, "Start CPR." The smell here is overpowering, like rotten eggs. Your eyes are watering, it's so strong. Suddenly, there's only silence, as if the emergency simply evaporated. Question number 1. What do you do next? A. Go inside to help with CPR. B. Call for help. C. Leave immediately. D. Find something with glucose in it. The answer is B. Call for help, though I won't fault you if you chose to leave, then call for assistance. Why not help? Because if you go inside that room, you made the wrong choice and you did not survive today's podcast. These people have been exposed to a knockdown gas. If you enter, you too will be dead and unable to help. If you ever see two people go into an enclosed space and don't come out, assume there's a toxic gas inside and don't become the third victim. You pull out your cell phone, relieved to see there's Wi-Fi down here. You cross your fingers and call 911, hoping it does something on a cruise ship. It does, and help is dispatched immediately. The extremely stinky sulfur smell dissipates. Question number 2. This means it's safe to go into the room. A, true, or B, false? The answer is B, false. If you answered this one wrong, you again didn't survive this podcast. More on this in a minute. First, let's jump right into question 3. What toxin have the ship's crew and medical staff been exposed to? A, chlorine gas, B, hydrogen sulfide gas, C, arsine gas, or D, carbon monoxide? The answer is B, hydrogen sulfide gas. Obviously, all of these gases are toxic. Only hydrogen sulfide, though, is a knockout gas, meaning it's the only one causing an immediate loss of consciousness and cardiac arrest. Carbon monoxide definitely causes loss of consciousness and death, but not instantaneously. Chlorine and arsine gases are poisonous enough to have been used or considered as weapons of mass destruction. Chlorine injures the lungs, and arsine causes hemolysis or rupture of red blood cells and renal failure. Both are lethal, but neither immediately so. Where is hydrogen sulfide gas found? Specifically, how can you make sure to avoid it, do I hear you asking? It's not something you're likely to encounter outside of specific jobs or scenarios. That said, a cruise ship is not your typical location. Hydrogen sulfide gas is a byproduct of anaerobic bacterial metabolism. Anaerobic bacteria are found in feces. The gas is produced as the bacteria break it down, meaning it's found in sewage pipes under cities or septic tanks in less urban locations, manure pits, It occurs naturally in the environment, in hot springs and gas and oil fields. If hydrogen sulfide is present, it's often called sour gas. Several people inside that room are dead or dying. It's not easy to stand by and wait. In fact, are we safe here? Should we take the elevator back up? That's a judgment call. We're currently standing in a large room, so even if present, hydrogen sulfide is likely in a low concentration. But it's no guarantee. The sulfur smell has dissipated. Why aren't we safe? And why might that mean we are, in fact, in grave danger? Crew members arrive in seconds after your call with scuba tanks and pull 5 people out of the room. The last 2 people who entered, the nurse and the crew member, have pulses and wake up immediately. So does a man wearing scrubs. The air in this larger room is safe, otherwise they wouldn't have woken up. You find out later the other room is really a very tiny, almost a crawl space. Unfortunately, the 2 original victims, Mike and Jose, don't wake up and don't have a pulse. You help with CPR, trying for 30 minutes, but it's futile. They're dead. The ship carries a multi-gas detector confirming your suspicions. This is hydrogen sulfide. What's the treatment for hydrogen sulfide gas? A, fresh air. B, dimercaprol. C, hyperbaric oxygen. D, methylene blue. The answer is A. Fresh air is absolutely critical. Oxygen is recommended for patients, however, there's no proven benefit from hyperbaric oxygen. Hydroxycobalamin and sodium nitrate are antidotes for cyanide poisoning. They may have some utility in hydrogen sulfide toxicity based on animal models. Why? Hydrogen sulfide's mechanism is similar to cyanide. More on that shortly. If those antidotes do work, they likely need to be administered within minutes of exposure, and that's just not a real-life scenario. This toxin is almost impossible to study in humans. Why? Because most of them are dead before reaching the hospital. These cases are extremely tragic, often claiming the lives of multiple victims and rescuers. In fact, 25% of fatalities typically involve the rescuers. These incidents most often occur during industrial accidents. In 2003, a Chinese gas drilling accident released a cloud of hydrogen sulfide, killing more than 200 people and injuring 9,000. 40,000 people had to be evacuated from the affected area. The gas occurs naturally in volcanoes, caves, and underground deposits. Non-occupational deaths are occasionally reported due to things like clogged drains and hot springs. For example, 2 people died at a hotel in Turkey with a thermal bath inside their room after hydrogen sulfide release from the illegal well. What does the gas do? It inhibits cytochrome oxidase, interrupting oxidative phosphorylation and resulting in energy failure, cellular hypoxia, and death. It binds in a similar location as cyanide and in fact binds with a higher affinity than cyanide does. How does it work so quickly? It is extremely lipid soluble, meaning it can rapidly enter the body and cross the blood-brain barrier. In the 2000s, you may remember hydrogen cyanide in the news used to commit suicide. These were referred to as detergent suicides. Victims mixed 2 household cleaners together, producing toxic hydrogen cyanide gas as a byproduct. I'm leaving out specific details so there's not enough information, as I do in all episodes, in case someone with self-harm or nefarious intent is listening. Suffice it to say, it's a very specific mixture. I've never heard of someone accidentally dying while cleaning the bathroom from hydrogen sulfide. News coverage, first in Japan, then worldwide, led to a chain reaction of suicides. More than 500 people died in Japan alone in 2008. This led to a call for the recipes to be scrubbed from the internet. I can attest to the fact that the information has become much more difficult to obtain via search engines, which is a good thing. A common scenario was as follows. EMS is called to a parked car with a deceased person inside. The victim mixed the chemicals in the enclosed space of the car and inhaled the gas. Since first responders can be exposed when opening the door, some posted signs warning of hazardous material inside the car. In other cases, the smell of rotten eggs in a building prompted an investigation, uncovering a person who'd committed suicide in their apartment. Neighbors might have symptoms like headaches and dizziness, and sometimes evacuations of the buildings were required. Hydrogen sulfide has a definite dose-response curve, meaning toxicity is correlated with the dose. At 1 part per million, you can smell it. At 50 to 100 parts per million, it causes nausea, vomiting, and eye irritation. Toxicology board question, this is called gas eye. At 500 to 1,000 parts per million, hydrogen sulfide has a knockdown gas effect with cardiac arrest. Astonishingly, a concentration of 1,000 parts per million is enough to stop breathing after just 1 to 2 breaths of this extremely poisonous gas. It has a horrible sulfurous rotten eggs odor. So why isn't it safe when the smell is dissipated? It's really interesting, and it's not because the gas can be odorless. It's because the gas damages and paralyzes the olfactory nerve, the nerve running directly from your nose to your brain, meaning you can't smell it when it's present in a high lethal concentration. Gas workers have disturbingly said when you stop smelling hydrogen sulfide, that's when you know you're really in trouble. Yikes. Neurological problems can be severe. In one series of 200 patients with hydrogen sulfide exposure, 75% lost consciousness immediately at the time of exposure. Some victims removed from the gas recover quickly and without sequelae. Others have long-term neurological deficits. In many cases, this may be the result of anoxic brain injury rather than directly from the hydrogen sulfide itself. Some victims never recover a sense of smell after severe exposure. Animal studies show hydrogen sulfide causes arrhythmias and inhibits cardiac contractility, meaning your heart can't squeeze or pump, resulting in ischemia and infarction. How do we test for it? We actually test for it in the environment rather than in the patient, and the best way is to test the air with a gas detector. Hydrogen sulfide can be tested for post-mortem, but it requires rapid sample collection because it degrades as the tissues degrade. Question number 4. What color might you see on autopsy in the organs after death due to hydrogen sulfide? A. Cherry red, B. Yellow, C. Black, or D. Green? The answer is D. Green. Autopsy shows green discoloration of the brain, lungs, and other organs. Back to our ship. The surviving patients include the ship's doctor and nurse. They received the call about 2 men down and ran to respond. The medical professionals started CPR before passing out themselves. The 2 dead crew members investigating the terrible smell found a leaking sewage pipe, also leaking the poisonous gas. The 3 survivors have no further medical problems. The sewage pipe is repaired and the toxic gas properly vented. Surprisingly, the ship doesn't alter its voyage, and passengers are never alerted to the danger. You consider faking a medical emergency to be airlifted off, but once the sewage smell clears, you assume reoccurrence is likely low risk. That said, this is probably your last cruise. As I mentioned, hydrogen sulfide occurs naturally in the environment. Deep-sea hydrothermal vents expel the gas, and creatures living near them have adapted to avoid toxicity. It's pretty cool. Worms, for example, contain trophosomes, sacs filled with bacteria which live on hydrogen sulfide. It's an amazing adaptation. It's theorized hydrogen sulfide caused a prehistoric mass extinction event called the Great Dying, killing more species than the dinosaur extinction. 95% of marine species and 70% of terrestrial species died during this event. And it's believed volcanic eruptions warmed the planet, starting a cascade of events resulting in increased anaerobic decay and increased hydrogen sulfide in the atmosphere. Despite its incredibly toxic nature, hydrogen sulfide is being investigated as treatment for things like stroke, wound healing, and cancer. Why? Well, we actually have hydrogen sulfide in our bodies. It's a signaling gas working as a neurotransmitter. So modulating hydrogen sulfide might reduce metabolic demands and inflammation. Researchers are investigating it as an adjuvant in cancer treatment. These investigations are in the early stages, but who knows? It's always fascinating to consider the therapeutic potential of lethal toxins. Question number 5. Hydrogen sulfide contributes to which of the following problems? A. Halitosis, or bad breath. B. Bad flatus, or smelly farts. C. Bromohydrosis, or smelly sweat. D. Malodorous pus. The answer is actually A and B. Hydrogen sulfide is made by bacteria in your mouth, contributing to bad breath. It's also made by bacteria in your gut, leading to smelly flatus. Pretty sure my dog has extra high levels in his gut, though I love him anyway. While researching for this podcast, I just learned about blood-borne halitosis, where compounds in the blood cause bad breath and bad body odor, which sounds absolutely terrible. Anyway, today's case is fictional, as are all our cases to protect the innocent, but it is based on real poisonings. The last question in today's podcast is a trivia question. Which of the following is an indicator of hydrogen sulfide exposure? A. Black discoloration of pennies. B. Cherry red blood. C. Green colored clothing. Or D. Yellow colored skin. Follow our Twitter and Instagram feeds, both at PickPoison1, and you'll see the answer when I post it. Remember, never try anything on this podcast at home or anywhere else. Finally, thanks for your attention. I hope you enjoyed listening as much as I enjoyed making the podcast. It helps if you subscribe, leave reviews, and/or tell your friends. All the episodes are available on our website, pickpoison.com, Apple, Spotify, or any other location where podcasts are available. Transcripts are available on the website. While I'm a real doctor, this podcast is fictional, meant for entertainment and educational purposes, not medical advice. If you have a medical problem, please see your primary care practitioner. Thank you. Until next time, take care and stay safe.
This podcast is a production of Unfiltered Studios. If you would like to know more about joining Unfiltered Studios, please visit our website at unfpod.com for more information.